This is Gabe Ignetti, and this is the Ecomodernist Soapbox. And I hope everybody is well. And today we have with us Meredith Angwin, and she is the author of a couple of books, and she could tell us a little more about that. But her book right now that she's done is Shorting the Grid, the hidden fragility of our electric grid. And she knows well about this because she is a chemist who's worked in the electrical industry. So how you doing, Meredith?
Fine, thank you. Glad to see you.
To start, your book was about electricity deregulation, and it predicted a disaster for this unregulated grid. How bad a disaster are we talking about, and how would it occur?
Well, I don't like to talk about total disasters, but basically, the part of the grid that is going to be in trouble is what they call the deregulated grid. It has tons of regulations. The first thing that is likely to happen, and it's already happened in California, it is likely to happen in the Northeast, is basically that there will not be enough electricity to go around during extreme weather. And during extreme weather, there will be rolling blackouts. Now, that stuff is bad enough. I've lived through it once in California. In all honesty, that's only the beginning of it, in my opinion, because what's going on is we have what I call the fatal trifecta, which is that people are putting a lot of renewables on the grid. And then when the renewables on the grid, they say, oh, well, the renewables go on and off rather quickly. So let's see if we can back them up with natural gas. Well, the thing about natural gas, as proven in California and pretty close to being proven in New England recently, is that you can only get as much as is available in the pipeline. You can't store it on site at a power plant. Some power plants have LNG on site, but not regular pipeline natural gas. And so in a bad weather situation, or if there's a compressor going out on a gas pipeline or whatever, you won't be able to get natural gas. Now, some of the RTOs say, well, yeah, but we have a three-link stool here. We have the renewables, the natural gas backup, and we can get energy from our neighbors. Well, the thing is, if you're talking about any kind of emergency, like a really bad cold snap, a really bad heat wave, or a really major compressor outage on a pipeline, the neighbors are probably in trouble too, and they're not going to be able to send you any electricity. So basically, the beginning would be rolling blackouts. And the thing is, what triggers the rolling blackout? How cold does it have to be? How much natural gas has to be not available? And you see, the thing is, the triggers can become less and less over time. If you don't change things, if you keep doing renewables plus natural gas backup, the triggers will become less and less. Maybe it took 40 below to trigger a rolling blackout. Maybe the next time it'll take 0.
Yeah, I understand. I've read that with the polar vortex, it was so cold that gas lines were freezing.
Well, the gas lines, the compressors weren't working as well, and it's not really cheap on the grid nowadays.
Yeah. Well, perhaps in the desert in Southwest. I mean, because you don't have intermittency, you could depend on it during the day to be there. Perhaps. I don't know.
I'm more concerned with, you have a nuclear plant, and it's bidding in at 4 cents per kilowatt hour, or 5, and it's about the same cost as everything else. But it may not be dispatched because a wind turbine, which if it had to make money by selling the kilowatt hours would be bidding in at 5 or 6, is actually bidding in at 0 because it gets outside funding from production tax credits and selling renewable energy certificates and so forth. So the wind turbine can even say, I'll pay you a penny a kilowatt hour to take my power. Many solar panels are in net metering programs. Means that, let's say I signed up for net metering and I have a solar panel in my house, or I share part of a community solar panel. And what that means is, let's say I'm out here in Vermont where my electricity is maybe 15 cents per kilowatt hour. I'll be paid 15 cents per kilowatt hour for every kilowatt hour of electricity that I supply to the grid,
No matter what.
no matter what. Because the idea of net metering is that when I supply a kilowatt hour of electricity, my meter runs backwards. So if I supplied as much as I produce, then I would have nothing to pay to the grid. Now,
Well, let me ask you. Let me ask you this: if, let's say that there's so much electricity on the grid that the price is zero, you still get your 15 cents?
oh yeah,
Wow, that's crazy.
so the thing is that people who have net metering, of course, they love it because they don't have to pay for electricity. Meanwhile, the people who don't have net metering, they're paying more. And and uh, and secondly, the net metering people aren't paying for all the other stuff. What I'm trying to say is you understand that your electricity company, your electrical utility, your local one, it doesn't just get generation. It has transmission lines, it has substations, it has people in the office that you can call if a line went down, it has people in the office you can call if you say, due to COVID, my husband was laid off and we need a way to finance my electric bill. It has all that stuff. And if you say, well, they're paying 5 cents for electricity, but they're charging me 12 cents, that's extra 7 cents isn't all profit for them. It's maintaining their lines, it's maintaining their
Yeah,
office, it's maintaining their billing. So the net metering people are not paying for any of that. They're not paying for the office, they're not paying for the lines, they're not paying for the billing.
really.
Well, yeah, because, well, let's put it this way, there's been a pushback. And now net metering, people who have net metering often have to pay a connection fee, which helps to pay for those other things.
It's just impossible without nuclear power in most places. You know, not everywhere. I mean, if you got a lot of hydro, if you got a lot of geothermal, but geothermal has problems. You were saying, and with pollution, could you speak about that a little?
The thing is that geothermal comes up from the ground. It's very natural. And that means that it comes up with a lot of hydrogen sulfide gas, which is the rotten egg smelling gas, which if you've ever visited a area that has natural geothermal like fumaroles and stuff like Yellowstone, wherever, you'll smell that gas. And when you begin bringing up geothermal, you end up producing a lot of that gas, and you have to have mitigation, you have to have pollution control for it.
That's toxic too.
Oh, it's
I
very
think.
toxic. We can smell it. It's the reason we can smell it that way is it's really bad. I mean, it kills people. And
Wow.
it also brings up a lot of other stuff from the earth. Some radiation. It does.
Yeah.
I think it does.
Not that it's that important. I mean, to me at least. I mean, radiation's overblown.
I agree with that. Yeah. So anyway, that's what I worked on. I worked on geothermal, and also I worked a lot on nitrogen oxide pollution, trying to minimize nitrogen oxide pollution. Nitrogen oxide pollution is when you have any combustion process, coal or oil or gas. In a way, I consider NOx to be one of the most intractable of the pollution problems that I've encountered.
Well, you know, I've heard that on a podcast. I mean, it was stated that hydrogen could become the replacement fuel, mostly or all for gas, and it could be piped in instead.
I remember reading an article, and I don't know who wrote it, but it was very praising about green hydrogen and how it's actually being used right now. And it turned out, yeah, it's being used right now. There's a process that's using natural gas, and they made green hydrogen by running wind turbines and using that power to break up water. And they put that green hydrogen in and about 5% into the methane. And now they say, look, you see, we're already using it. I'm like, yeah, at 5%. And from my point of view, that green hydrogen is just greenwashing. It's like, we're so great.
I'm sure it's no matter what, it's expensive.
You know, there's this whole thing going on like, we've got to decarbonize everything. We've got to decarbonize our transportation and our heating, home heating, and our whatever. And that's fine, and I think we should. But instead of worrying about all of that, why don't we start by decarbonizing the electric grid, which is something we know how to do? I'm not sure we know how to decarbonize transportation. I mean, it could be done, but what I'm trying to say is I would love to see the electric grid decarbonized as part one.
Absolutely. You mentioned too, like in your book about synchronicity being a problem. If you could explain what that is.
Yes, I will try, but I'm not an electrical engineer. What I'm trying to explain is that, for example, the grid is used to rotating generators. That is, you have either a hydro plant, an internal combustion engine, or a steam turbine. And each of these turns a turbine of some kind, which turns a generator, the generator turn, and it makes AC electricity that goes out on the grid.
It's
And the
smooth.
whole process
Yeah.
is very, very controlled. So now we have wind turbines and solar plants, and neither of them have spinning machinery.
They don't spin all the time at the same speed, the wind turbines, right? So
Exactly.
it's spinning
so
machinery, but
so they both make DC power.
yeah.
They take the rotating, the AC power, whichever frequency it is, turn it to DC power, and then turn it back to AC power at the same frequency as the grid and put it on the grid. Now, there's nothing intrinsically wrong with doing that. The thing that does the change from the DC power to the AC power is called an inverter. The thing is that inverter power is a little bit different. Inverter power made from DC to AC is AC power, but it has some different characteristics than AC power made by spinning machinery. And so the grid operator has to be aware of those characteristics. And in many cases, something has to be done about them. For example, in a set of wind turbines that were put on the grid in Vermont, they were being curtailed a lot because they didn't match with the grid well, even though they were synchronized to it. The other things like inertia and VARs and all this electrical engineering stuff that I don't want to go into because it's complex and I'm not sure I could.
It's too wonky. It's too wonky. I got you.
Too wonky. But when you get right down to it, there are things besides frequency and voltage that have to be matched. And the wind turbines had to build a $10 million synchronous condenser before they were allowed on the grid a lot. And nobody talks about that in terms of levelized cost of electricity. They're always talking about how expensive it is to build the wind turbine itself.
That's really expensive.
Yeah, it is pretty expensive. I mean, you see that. I'm just trying to say that people act as if you can just switch in and out rotating electric machinery and inverter power, just switch it, no problem. The grid operator doesn't look at it that way.
Well, I think people who believe in renewables, it's based on trust. They don't trust the fossil fuel industry. I don't blame them. But they put their trust in Greenpeace. And these are good guys. They wouldn't lie to us. I think that's basically as far as most people take it. And that's where we come in. As long as people, at least the people are open-minded.
I hope people will become more open-minded. And I also hope that people will buy my book, not because I hope to get rich from it, but because, as you say, it's a complex subject. I don't know if hundreds of thousands of people are going to want this book.
I hope
but
so.
I want people to be aware of the way choices on the grid are affecting what's going on and be willing to take some action. Like the next time someone tells you that wind is the cheapest thing on the grid, it isn't. It's only the cheapest thing in the kilowatt hour auctions.
Yeah.
Which is not the same as saying putting wind on the grid is going to lower your bill at home. It isn't.
Yeah, I got you, man. I got you. Well, before we go, why don't you show us your book? Show us both of the books.
Well, here is Shorting the Grid. It covers subject about grid decision making that it's comparatively hard to find without this book. I'm not trying to boast. I'm just saying I've got a lot of books about the grid, and none of them seem to cover the RTO decision making process and so forth. Those things are tremendously important.
Yeah, I've read it. I could attest to that. It really gets down to the nitty gritty.
And then here's my book, Campaigning for Clean Air, which is about how to support nuclear power.
Yep.
Campaigning for Clean Air, Strategies for Pro-Nuclear Advocacy. And the reason for this book is to have people be able to see a way to go forward. I mean, if you try to figure it all out on your own, it's not so easy. But for example, in this book, I have how to write a good letter to the editor, or how to get an op-ed published, or remind your local reporter that you're available for a he said, she said quote if something goes on about nuclear, and things like that, as well as rallies and marches and all that, because a lot of people don't want to do rallies and marches.
Yeah, I hope more do. Well, thank you for joining us, Meredith. It's been a real pleasure.
Thank you.
I want to thank our viewers for tuning in, and stay well, and we'll be seeing you till next time.